Hello everyone, week 2 part 2. Logical operators are used to create relational expressions from other relational expressions. Relational operators can be used to test whether a particular condition is true or false. They can only test one condition at a time. So if we need to know whether multiple conditions are true at once, for example, to check whether you won the lottery, we have to compare whether all the numbers we picked match all of the winning numbers. So let's say in a lottery with 6 numbers, this would involve 6 comparisons, all of which have to be true. Other times we need to know whether any one of multiple conditions is true. For example, we may decide to skip work today if we're sick, if we're too tired, or if we won the lottery in our previous example. This would involve checking whether any of the 3 comparisons is true. Logical operator provide us with this capability. And C++ has 3 logical operators: logical AND, logical OR, logical NOT. Logical AND, the symbol is 2 ampersand, so it's ampersand ampersand. For example, X and Y. The operation is true is if both X and Y are true, false otherwise. So both have to be true for the operation to be true. Logical OR, the symbol is X or Y. The operation is true if either X or Y are true, false otherwise. So at least one of them has to be true for the operation to be true. Logical NOT, the symbol is exclamation mark. For example, not X is true if X is false, or false if X is true. So it's opposite of what X is. The logical AND operator is used to test whether both conditions are true. So if both conditions are true, logical AND returns true. Otherwise, it returns false. The logical OR operator is used to test whether either of 2 conditions is true. If the left operand evaluates to be true, or the right operand evaluates to true, the logical OR operators return true. If both operands are true, then logical OR will return true as well. If logical NOT's operand evaluates to true, logical NOT evaluates to false. If logical NOT's operand evaluates to false, logical NOT evaluates to true. In other words, logical NOT flips a Boolean value from true to false or vice versa. An example of the logical AND operator is a program we might want to know if the user is qualified for a loan based on 2 conditions: if the user is employed and if the user recently graduated. In this case, we use the logical AND operator to test whether the left condition, employed, is yes, and the right condition, recently graduated, is yes. If both are true, the logical AND operator evaluates to true, and the if statement executes. If neither are true, or only one is true, the logical AND operator evaluates to false, and the else statement executes. With logical OR, we use the operator to test whether either the left condition, in this case income is greater than or equal to min income, or the right condition, years greater than min years, is true. If either or both are true, the logical operator evaluates to true, which means the if statement executes. If neither are true, the logical OR operator evaluates to false, which means the else statement executes. In the case of the logical NOT operator, the inside of the parentheses, income greater than or equal to min income or years greater than min years, will be evaluated first. And the logical NOT will flip the Boolean result. So if the OR result is true, the NOT will flip that to false, and the opposite is true as well. So if the OR result is false, the NOT will flip that to true. Some guidelines about logical operators. NOT has highest precedence, followed by AND, then OR. So NOT, then AND, then OR. There's what's called short circuit evaluation. In order for logical AND to return true, both operands must evaluate to true. If the first operand evaluates to false, logical AND knows it must return false regardless of whether the second operand evaluates to true or false. In this case, the logical AND operator will go ahead and return false immediately without even evaluating the second operand. This is known as short circuit evaluation. It is done primarily for optimization purposes. Similarly, if the first operand for logical OR is true, then the entire OR condition has to evaluate to true, and the second operand does not need to be evaluated. Short circuit evaluation presents another opportunity to show why operators that cause side effects should not be used in compound expressions. Consider the following example or snippet. For example, if x is equal to y and y plus plus equal to 2, do nothing. If x does not equal 1, y plus plus or y increase, which increment, gets evaluated. Thus y will only be incremented if x evaluates to 1, which is probably not what the programmer intended. New programmers sometimes confuse the logical operator AND with the bitwise AND operator, which is one single ampersand, not two. Even though they both have AND in the name, they perform different functions. Mixing them up can lead to incorrect results.